All right, so we have to determine if something's linear or not linear, and then we have to explain why. What do you think the first one is? Not linear. Okay, you're right. It's not linear. But why? Yes.
It's not linear because it does not represent y equals mx plus b.
Right, so I'm going to say not y equals mx plus b, but there's more. Why? I'll tell you, this is technically called, well, because x is squared. Okay? If you were in my algebra class, I would say because it's a second degree polynomial, which is kind of a fancy way of saying that it's x squared. What about 4? Is that linear?
Yes.
Yes. Why?
Because it has the y equals mx plus b.
Yep. Y equals, and let's say it like this, mx to the first power plus b. But I'm going to say but, or I'll say actually, y equals, could I say b plus mx?
Yeah.
Yeah, they're just flip-flopping those two terms around a little bit. Okay? Now, for the last one, it says, explain how you can use the table of values of an equation and graph to determine if the function is proportional or not. Well, what does that mean? Well, explain to me what that process would be like. Yes.
Like it helps you figure out what the x and b can be.
Yeah, so I like what you said there. I'm going to word it a little more fancy, okay? For proportional relationships, and I'll fix this in a second. For proportional relationships, the equation must be linear and have a y-intercept of what? 0. B equals 0. The line must pass through, what do we call that spot where it has to pass through 0, 0? Origin. Good. So then I would say when you graph the points, they need to make a straight line and pass through the origin. Okay? That's how you know. You're going to plug the numbers in, see what you get. Okay? They're going to give you a bunch of x's and y's. You plot the x's and y's, connect the dots, and once you connect the dots, if it makes a straight line, awesome. Then we know it's linear. If it passes through the origin, then we know it's proportional. Okay? Any questions on that? I think